Okay, let's dive in. So imagine this. You've done it. You built that first thing, that MVP, your minimum viable product.
You have the lean version?
Exactly. And maybe, surprisingly, maybe not, it actually takes off. People are using it. Real users.
That's the dream, right? Seeing it connect.
Totally. Revenue might even be starting to trickle in. That little graph is ticking up. It's exciting. There's this real energy.
Absolutely. It feels like validation. Like, okay, this idea has legs. You're moving fast, learning, iterating.
You feel like you're riding this awesome wave.
Yeah.
But then, well, then things can start to get a bit choppy, can't they?
Uh-huh. The very thing that made you successful, that rapid growth, starts to strain the system itself.
Yeah, the sources we've been digging into for this deep dive, they paint a really vivid picture of this phase. It's often where the cracks start showing.
Big time.
Like bugs aren't just occasional anymore. They start piling up. It feels like you fix one, two more appear.
Yeah, whack-a-mole. And deployments. Oh, man.
Deployments go from being routine to being, well, terrifying. You push the button and just hope nothing explodes.
Fingers crossed, deep breaths. Because sometimes it does explode.
Right, and trying to onboard new people, if you're lucky enough to be growing the team.
It can be a nightmare. They walk into this code base that maybe only one or two people really understand.
It's like handing them spaghetti and saying, okay, untangle this.
Exactly. It slows everything down. Your success starts actively fighting against you.
That inflection point, that crisis moment, is exactly what we're focusing on today. We've looked at material that really dissects this critical stage.
Moving beyond that initial burst.
Yeah. The mission here is to unpack the common traps, the pitfalls engineering teams stumble into when they scale fast. But more than just the problems.
We need the solutions, or at least strategies.
Exactly. Practical strategies the sources suggest to get out of that reactive firefighting mode.
Towards something more sustainable. Future-proofing, you could call it.
Yeah, I like that. It's like you build a garden shed, it got really popular, and now you realize you actually need to build a skyscraper on that same spot.
Right. Different foundations, different mindset required.
So for you listening, maybe you're leading a team, maybe you're managing tech, maybe you're coding solo on a project that's taking off.
This is probably something familiar to something you might face soon.
This is kind of a survival guide. We're pulling insights from these sources on how to build that foundation, the code, the infrastructure, the team processes, in a way you won't regret down the line.
Building something maintainable, something you can keep growing.
We'll touch on the key things the sources highlight. That big mindset shift, tackling testing before it blows up, building infrastructure intentionally, managing code complexity.
Don't forget technical debt and onboarding, team culture. It's all connected.
Totally. It's a whole system. So let's start where the material suggests we should start, which isn't actually with code, interestingly enough.
No, it starts higher level. It starts with how you think.
The foundational shift, moving away from that pure MVP mindset.
Right. And let's be clear. The sources absolutely acknowledge the power of the MVP approach initially. Speed, simplicity, iteration, they're vital.
You need to get off the ground to validate the idea without overbuilding. Just ship.
Yeah.
It works.
It absolutely works. For that phase, you need that quick feedback loop. But the danger zone, according to the analysis, is keeping that exact same mindset for too long.
When does it become dangerous?
When the scale changes dramatically, when complexity increases, clinging to just ship it above all else starts becoming, and the sources use this word, toxic for sustainable growth.
Toxic. Wow. How so?
Because it directly leads to what they call brittle systems. Things built quickly, maybe with shortcuts, under assumptions that don't hold true anymore when you have way more users or data.
Oh, things break easily, unexpectedly.
Exactly. You touch one part, and something seemingly unrelated falls over, confidence drops, fear creeps in.
Okay, so the shift isn't about stopping shipping things. It's about shipping smarter.
That's the phrase used, yeah. Ship it smart. It means you're still moving, still delivering, but you're also considering the future implications.
So not just speed, but speed plus maintainability or future cost.
Something like that. It's a balance. Asking yourself, okay, this is fast now, but is it going to cost us 5 times as long to change it later? Or is there a slightly cleaner way that doesn't add much time but avoids a future headache?
It's introducing that long-term perspective alongside the short-term pressure.
Exactly. And the sources are really insightful about why this is so hard to do in practice.
Pressures are huge, right? Investors want growth now. Sales wants features now.
Market demands, competitor moves, it all screams faster. There's this feeling that pausing, even for a moment, to refactor or write better tests means falling behind.
Like you're on a treadmill that's constantly speeding up. Stepping off feels impossible.
It does. The perceived immediate cost of slowing down feels way too high.
But the argument is that not making this mindset shift early enough is actually the root of so many later problems.
That's the core thesis. Failing to evolve the thinking causes the technical nightmares down the road. The testing gaps, the shaky infrastructure, the tangled code. They often start here.
It's the original sin, in
Yeah.
a way. Okay, so let's say you've started to internalize this need to ship it smart. What are the first big technical areas where the wheels usually fall off if you haven't? The material points strongly at testing, or rather the lack of it.
Yes. The testing time bomb. It's such a common story.
You start out, you're moving fast, maybe doing some manual checks.
Just clicking around, making sure the main path works. Because writing comprehensive automated tests feels slow, like overhead you can't afford yet.
You make that gamble, we'll add tests later.
Right. And maybe for a tiny app with few users, you get away with it for a bit. But as the system grows, more code, more features, more edge cases, more users hitting those edge cases.
The odds change.
Dramatically. That gamble turns into a huge liability. The bomb starts ticking louder.
And the explosion. What does that look like day to day? The sorts is mentioned debugging in production. Ugh.
Yeah, that's panic mode. Trying to diagnose and fix a live issue while users are affected, potentially losing data or trust. It's incredibly stressful, high risk.
And expensive. Developer time, yes, but also business costs.
Absolutely. And the other big one is regressions. Constant, painful regressions.
Explain that again. What's a regression in this context?
It's when you make a change. Could be a new feature. Could be a bug fix. And that change unintentionally breaks something else, something that used to work fine.
Like fixing the login page somehow breaks the payment processing.
Exactly. Seemingly unrelated things start failing, and without automated tests covering those areas,
You don't find out until users complain.
or until QA finds it much later, slowing down the release. Or worse, it slips through to production. Suddenly your team feels like they're spending all their energy just fixing things they broke themselves.
Progress grinds to a halt.
Oh.
Okay, so the material obviously recommends building automated tests. But how do you do that without killing velocity, especially if you're starting from behind?
Strategically, that's the key word. The sources emphasize it's not about trying to achieve 100% test coverage overnight on a legacy system. That's often impractical and demoralizing.
So where do you start?
You prioritize. Focus your efforts on the most critical areas first. What parts of your system absolutely cannot break? What's the core business logic? Where are regressions most likely or most damaging?
Like the payment flow you mentioned,
Yeah.
or core user actions.
Exactly. Start there. Write good, solid tests for those critical paths. Maybe integration tests that cover key user journeys, maybe unit tests for complex calculations or business rules.
Choosing the right type of test for the job.
Yes, and integrating testing into the workflow. Make it part of the definition of done. Code isn't finished until it has reasonable tests. Run tests automatically in your CI/CD pipeline.
So it becomes part of the habit, part of shipping it smart.
Precisely. And the payoff, the ROI described, is immense. It's about confidence.
Confidence to deploy.
Confidence to make changes. Knowing you have a safety net that will catch many regressions automatically frees the team up. You spend less time manually testing, less time debugging fires.
And paradoxically, you can actually move faster overall because you're not constantly tripping over old mistakes.
That's the long-term win. It flips the script. Investing a bit more time up front saves vastly more time and pain later.
It really makes you weigh that initial save day against the weeks you might lose later, doesn't it?
It forces that uncomfortable but necessary calculation.
Okay, another area that often gets overlooked early on is infrastructure. You start simple, right?
Makes total sense initially. An MVP probably doesn't need a globally distributed auto-scaling Kubernetes cluster.
Maybe just one server, a basic database, keep it cheap and easy.
Yeah, enough to handle those first users. But the sources point out this becomes a major bottleneck, often quite suddenly.
Traffic spikes or the application just gets heavier.
And that simple setup just falls over. Performance tanks or the site goes down entirely.
The material flags some specific shortcuts here that cause problems later. Manual deployments are a big one.
Still surprisingly common. Someone SSHing into a server, pulling code, restarting services by hand.
What's wrong with that besides being slow?
It's incredibly error-prone, especially under pressure. Miss one step, mistype a command, boom. And rolling back can be just as manual and risky. Consistency is hard to achieve.
Okay. Then there's the lack of observability. What does that mean?
Basically, flying blind, not having good logging, monitoring, or tracing in place.
So when things go wrong,
You don't know why. Is the database slow? Is the network flaky? Is one specific service overloaded? Is there an error spike? Without observability tools, you're just guessing. Diagnosis takes forever.
you can't fix what you can't see.
Exactly. And the third one mentioned is often starting with monolithic hosting.
Everything running together on one machine or instance.
Yeah. Which is simple at first, but makes scaling hard. If only the database needs more power, you might have to scale up the entire machine, which is inefficient. And there's no isolation. If one component crashes, it can potentially take everything else down with it.
Okay, so how do you climb out of that hole? Again, the advice seems to be gradual evolution, not a big bang rewrite.
Absolutely, step-by-step improvements. The sources consistently point towards things like CI/CD.
Continuous integration, continuous deployment, automating the build, test, deploy pipeline.
Huge win. Makes releases faster, reliable, repeatable, less stressful. Takes human error out of the equation for the most part.
What else?
Containerization. Using tools like Docker, conceptually speaking. Packaging your app and its dependencies together.
Makes it run consistently anywhere.
Yeah, and makes scaling much easier. Need more capacity for your web service? Just spin up more containers. It simplifies deployment and management.
And tackling that blindness.
Really?
The observability issue.
That's where proper monitoring and logging come in. Setting up tools to collect metrics, CPU, memory, request times, centralizing logs so you can actually search them. Maybe adding tracing to see how requests flow through different services.
Giving yourself instrumentation, like a dashboard for your system's health.
Exactly. You need those dials and gauges. Again, you don't have to boil the ocean on day one. Start monitoring key things. Implement basic CI/CD. Maybe containerize one service.
Incrementally build that more robust foundation.
Because good infrastructure isn't just about stability, it enables future growth. It removes blockers that would otherwise strangle your ability to scale features or users.
Right. Okay, infrastructure is one piece. What about the code itself? That code base gone wild scenario.
Yeah, this hits home for a lot of teams. Code bases naturally grow. More features, more developers, complexity increases.
And if it's not managed, it just becomes a mess.
A tangled mess. The key problem highlighted is often a lack of modularity.
Modularity, meaning breaking things into smaller, independent parts.
Exactly. Components or modules or services that do one thing well have clear boundaries and interact in defined ways. Without that, you get spaghetti code. Everything depends on everything else in weird, undocumented ways.
Leading to things like God objects.
Ugh, yes. Those giant classes or modules that seem to do everything, they started small, but every new related feature just got tacked on because it was easiest. Now they're huge, impossible to understand fully, terrifying to change.
And hard to test, presumably.
Incredibly hard to test in isolation. And they become bottlenecks for development. Everyone needs to touch the God object, leading to merge conflicts and coordination nightmares.
What are the warning signs that your code base is heading this way? The sources mention duplicate logic.
Copy-paste coding. You need similar functionality somewhere else, so you just copy a chunk of code. Fast now, disaster later when you need to update or fix that logic in 5 different places.
Unclear ownership is another one.
Yeah, when nobody really knows who's responsible for a particular part of the system because it's so tangled. Things get neglected, bugs don't get fixed, improvements don't happen. It's orphan code.
And fragile features the classic, fix one thing, break 3 others.
That's the direct result of those hidden tangled dependencies. Changes have unpredictable ripple effects.
So how do you fight back? How do you introduce structure? The material talks about clean architecture patterns.
Great, but it's less about dogmatically adopting one specific named pattern, more about embracing the principles. Separation of concerns is the big one.
Dividing code into layers or sections with specific jobs.
Yeah, like having a distinct layer for your user interface, another for your core application logic, another for your business domain rules, and another for data access. And having dependencies flow cleanly, usually inwards. UI depends on application logic, but application logic doesn't depend on the UI.
Makes it easier to swap out parts, like change the UI without rewriting the core logic.
Exactly. And easier to test parts in isolation. It brings order to the chaos.
Building better abstractions is mentioned too.
That's about creating reusable components or functions that hide complexity behind a simple interface. Instead of everyone needing to know the messy details of how, say, user permissions are checked, you provide a clean check permission function they can call.
Hiding the sausage making.
Pretty much. Good abstractions make the code easier to use correctly and easier to maintain because you only need to update the implementation in one place.
The overall benefit of focusing on modularity seems huge. Easier to understand, easier to change, easier to test.
And crucial for scaling the team. If the code is modular, different people or teams can work on different modules concurrently without constantly stepping on each other's toes.
It enables parallel work, which is essential as you grow. Without it, adding more developers can actually slow things down.
It's a phenomenon known as Brooks's Law. Adding manpower to a late software project makes it later, often because of the communication and coordination overhead in a non-modular system.
Okay, this leads nicely into the next big area, managing the consequences of past decisions. Let's talk technical debt. The sources are clear. It's unavoidable.
Completely unavoidable. If you want to ship software at any reasonable pace, you will make compromises. You will take shortcuts. Technical debt is just the implied cost of doing that.
The cost of choosing speed or simplicity now, which you'll pay later through increased effort or risk.
Exactly. Think of it like financial debt. You borrow time now, but you pay interest later. The interest might be slower development, more bugs, harder maintenance.
But the material makes a really interesting distinction here between good debt and bad debt. That's not something you always hear talked about.
It's a crucial refinement. Not all debt is created equal.
So that's good debt.
Good debt is strategic, intentional. It's a conscious decision to take a specific, known shortcut to achieve a valuable near-term goal. Maybe hitting a critical market window, landing a huge client, running an essential experiment.
So you know you're cutting a corner, you know roughly what the future cost will be, and you have a reason for it.
Yes, and ideally, you have a plan, even if informal, to pay it back. Like, we'll hard code this config now to launch next week, but we'll build the proper config system in the next quarter. It's a calculated trade-off.
Okay, makes sense. So what's bad debt?
Bad debt is the unintentional kind. It accumulates through neglect, carelessness, poor practices, maybe lack of knowledge, or just constantly rushing without thinking about the consequences. It's the messy code, the missing tests, the undocumented complexity that just sort of happens.
Your debt you didn't even realize you were taking on.
Often, yeah. Or debt you took on carelessly. It's unplanned, the cost is usually underestimated, and the interest compounds quickly and unpredictably, making everything progressively harder.
It's like leaky plumbing slowly ruining the foundations versus taking out a planned loan for an extension.
That's a great analogy. And the sources warn that letting bad debt, especially pile up unchecked, leads to a terrifying state: tech bankruptcy.
Tech bankruptcy sounds final.
It pretty much is, for the current state of the system. It's the point where the cost of making any change becomes prohibitively high. The system is so fragile, so complex, so burdened by debt that development grinds to a halt.
You can't build new features anymore.
Or it's incredibly slow and risky. The team spends almost all its time just fighting fires, keeping the existing broken system alive. Innovation dies. Morale plummets. The only way out might feel like a complete rewrite, which is itself hugely risky and expensive.
A truly dire situation. So how do you avoid that? How do you manage the debt you inevitably incur?
The material suggests putting actual systems in place for managing it, not just hoping it gets better.
Like what?
Things like establishing engineering health budgets, allocating a specific percentage of your team's capacity, say 10%, 20% in every sprint or cycle, specifically for paying down tech debt.
So it's not if we have time, it's planned, budgeted work.
Exactly. It makes it visible and prioritized. Another tactic is dedicated refactoring sprints or cleanup weeks, periods where the team explicitly pauses new feature work to tackle a significant chunk of known debt in a focused way.
Like spring cleaning for the codebase.
Yeah. The core idea is intentionality. You have to acknowledge the debt, track it somehow, even just a list, understand its impact, and have a deliberate strategy and allocated resources for paying it down over time.
Active management, not passive accumulation.
That's the only way to prevent sliding into bankruptcy.
Okay, shifting gears slightly, but still related to scaling pains,
Yeah.
growing the team itself. The sources highlight how onboarding new people can become a massive bottleneck if you're not prepared.
Yeah, if the system is complex and poorly documented and all the critical knowledge lives in the heads of a few veterans,
The bus factor problem.
like-
If one key person leaves.
a huge chunk of understanding walks out the door. And bringing new people up to speed takes forever. They're constantly asking basic questions, blocked, unable to contribute effectively for weeks or even months.
It really drags down the productivity of the whole team, not just the new person. So how do you build for easier onboarding? What helps?
It starts with the code itself. Writing clean, readable, self-documenting code is foundational.
Self-documenting, meaning the code is so clear it almost explains itself.
Ideally, yes. Good variable names, small functions that do one thing, clear structure, consistency. It means someone new can often read the code and get a decent understanding of what it's trying to do without needing tons of external explanation.
Reducing reliance on separate, potentially outdated documentation.
Exactly, but you still need some documentation. The sources stress creating comprehensive onboarding docs.
More than just, here's the Wi-Fi password.
Definitely. Guides to the overall system architecture. What are the main pieces? How do they fit together? Key workflow explanations, how to set up your development environment. A map of the important parts of the code base. Checklists for the first week.
Things to flatten that initial learning curve.
Massively. It empowers new hires to find answers themselves and become productive faster. Code walkthroughs are also mentioned as very effective.
Like a guided tour.
Yeah. An experienced team member sits down with a new hire, or several, and walks them through a key part of the system, explaining the design choices, the history, the tricky bits. It's invaluable for transferring that deeper context.
And fostering mentorship practices.
Things like pairing programming, where two devs work together on the same code. It's amazing for knowledge transfer. Also, having a code review culture that's focused on learning and constructive feedback, not just finding flaws, maybe assigning buddies or mentors.
Investing in these things, clean code, docs, walkthroughs, mentorship, seems like it pays off significantly in team velocity and resilience.
Huge ROI. Faster onboarding means faster time to productivity for new hires. Spreading knowledge reduces the bust factor risk. It makes the team less fragile when people inevitably join or leave.
It's building a scalable team process alongside the scalable technical system.
You absolutely need both.
Okay, finally, let's talk about the culture. Because all these technical challenges, the bugs, the debt, the frantic pace, they don't happen in a vacuum. They deeply affect the people involved.
The human cost can be immense. Constant pressure, firefighting, dealing with unreliable systems. It leads to burnout, plain and simple.
And the sources connect this technical mess directly to what they term cultural debt. What is that?
It's the negative impact on team culture that accumulates from unresolved technical problems and the unhealthy dynamics they create.
What are the symptoms of cultural debt?
Rushed decisions become the norm. Because everyone's always under pressure, thoughtful consideration goes out the window, which often just creates more technical debt. It's a vicious cycle.
Yeah, you can see that happening easily.
Lack of alignment is another symptom. When things are chaotic, communication breaks down, people work in silos, priorities get confused, there's no shared vision or clear path forward.
And the impact on morale.
It can be devastating. Constant frustration, feeling powerless against the tide of problems, maybe finger pointing or blame. Trust erodes trust in the system, trust in leadership, trust between team members. It makes for a really unpleasant and unproductive environment.
So how do you build a culture that resists this, that supports sustainable development? Leadership plays a huge role here, according to the material.
Absolutely crucial. Leaders need to actively encourage and value maintainability.
Meaning
that work like refactoring, writing tests, improving docs isn't seen as overhead or nice to have. It's recognized and rewarded as essential engineering work, just like shipping new features. It needs to be built into planning and expectations.
shifting the incentive.
Yes. Promoting clarity is also key. Clarity in goals, requirements, communication, processes, and even in the code itself. Reducing ambiguity reduces friction and mistakes.
And fostering collaboration.
Breaking down silos. Encouraging practices like pair programming, knowledge-sharing sessions, blameless postmortems when things go wrong, creating an environment where it's safe to ask questions, admit mistakes, and work together on hard problems.
It sounds like a healthy culture is almost a prerequisite for tackling the technical debt effectively.
It really is. You need that foundation of trust, psychological safety, and shared purpose to do the hard, sometimes unglamorous work of cleanup and building for the long term. The culture enables the technical recovery.
To wrap up the main points, the sources also draw on real-world examples, right? Stories from companies that went through this fire and came out the other side.
Yeah, implicitly or explicitly, the material reflects lessons learned from teams that have navigated this successfully. They serve as both cautionary tales and proof that recovery is possible.
What are the common threads in those recovery stories? How did they turn things around?
One key thing is recognizing those red flags we talked about early enough. Acknowledging, okay, the way we're working isn't sustainable. The pain is too high.
Admitting there's a problem.
Yes. And then, crucially, prioritizing the fixes. You can't fix everything at once. Successful teams figured out how to identify the biggest sources of pain or risk and tackle those strategically.
Focused effort, not trying to boil the ocean.
Exactly. And these stories ultimately show the transformation. Fragile MVPs, drowning in debt and complexity, gradually evolving into robust, maintainable systems that could support continued growth healthily.
So it's possible to climb out of the hole. It requires deliberate effort, leadership commitment, a plan.
And that fundamental shift in mindset. But it demonstrates that the initial shortcuts don't have to be a death sentence if you consciously decide to change course.
That's a hopeful note. Okay, let's try to pull this all together. We've
Okay.
gone through a lot in this deep dive.
It's been a journey from that initial MVP excitement to the complexities of scaling.
The core message seems to be that scaling successfully isn't automatic. It requires a conscious transition.
Yeah, a transition from pure hustle mode to a state of technical health and intentional development, moving from reactive firefighting to proactive sustainable building.
And the material consistently points to those key investments: testing, code structure, infrastructure.
Investing time and effort in automated tests for confidence and long-term speed.
Structuring your code thoughtfully for clarity, modularity, and maintainability.
Building infrastructure that enables growth, provides visibility, and automates deployment.
These aren't just technical nice-to-haves. They're strategic pillars for sustainable success.
Absolutely.
And importantly, the message isn't necessarily rewrite everything. It's about having a plan, making conscious choices, and chipping away at the problems incrementally.
Stop digging the hole deeper and start building stairs out. Make choices today that your future self and future team members will thank you for.
It's about making future progress less painful, more sustainable.
Exactly.
So to leave everyone with that final thought, that really resonant quote from the material: because the only thing worse than failing fast is succeeding with a system you can't maintain.
Ooh, yeah, that hits hard, doesn't it?
It really does. Failing fast, you learn, you move on. But achieving success, getting users, building something people want, only to have it crumble because the underlying tech can't support it.
That's a uniquely painful kind of failure. The success becomes the source of the failure. It's a trap you build for yourself.
A powerful idea to reflect on. Are the systems you're building set up for maintainable success, or are they potentially heading towards that trap? Worth considering.
Definitely food for thought. Check for those red flags.
Well, this has been a fascinating deep dive. Thanks for unpacking all that.
My pleasure. It's a critical topic for anyone building software today.
Indeed. And thank you all for listening.